Hello, this is Sean from Tech Training Solutions, here to start a new series on how to be an electrician. This is the first of many that I'll be helping you develop your talents and skills, at least mentally, on how to be an electrician. These are things that you should know prior and develop before you become a certified master electrician or journeyman electrician. If you're just an apprentice, you're going to learn this. If you're not, and you're just working in the field, I request that you start learning this stuff. This is going to help in many ways. If you're already good at physics and you understand that world, then you're great. If you're not, please pay attention for the next few minutes. There's only going to be 6-7 minutes. We're going to just break down briefly on the basis on this first episode. The Basic Electrical 100. This will cover the fundamentals of electricity, why it works, how it works, and why do you need this as an electrician. Electricians have to know certain information for troubleshooting, for determining sizing of your service, sizing of a breaker. Why do you need a 30 amp breaker? Why do you need a 40 amp breaker? This is going to help you at least understand the works behind the mysteries of electricity. What is electricity? Electricity is the flow of electrons through a conductor that turns on your lights, turns on your heater, your oven, and other things, including your car. You need electricity for that. Now, there's key components. The key components are voltage. Voltage is the pressure, the push, amperage, current, resistance. That is the opposition of current flow, and power. Power is the accumulative of all. These four fundamental elements in electrical systems is needed to know. Because if you know these systems, you understand it, you'll be able to understand why you have 120 volts here, but yet you're at this other location, you have 108. Why is that? There is a reason. These basic understandings will help you figure that out. So let's move on to electrons. This is what the current is. Electrons are tiny negative charged particles that orbit the nucleus of an atom. When they move through a conductor like copper, aluminum, they are basically electrical current. For electricians, understanding electrical flow is essential in the basis of electrical work and troubleshooting. For instance, if you have a motor that's running at 1.5 amps and all of a sudden it's running 5.4 amps, well, there's a reason. If you understand that reason and understand current flow, you'll figure it out. Now, with the current flow, there's so many electrons that flow through that wire. What is that called?
Coulomb.
In reference to amps or current. How many electron flows in 1 second in 1 amp? Well, one is 6.242 times 10 to the 18th power. That is equal to 1,000, 100, million, billion, trillion, quadruple trillion, 6. That's a lot of electrons in 1 amp. It's a massive amount of electrons. What is voltage? What is voltage? Let's think about this. Well, think about your house. You got 120 volts in that outlet, right? Your oven is 240 volts. What is that doing? Well, it's the pressure. It's what's providing you those amps. It's pushing those amps to your appliances. Think of water pressure, right? The bigger the hose, the more pressure you have, the more flow you have. The lower the pressure, the smaller hose, the less pressure you have. That is the same concept in electrical. Voltage is the electrical potential, difference in potential, the push of electrons. Think of, again, water hose. The higher the voltage. So if you notice that, right, as I turned on the faucet, the pressure the whole time was the same. But as I closed the faucet, right, the handle, lower the amperage would flow, lower and lower. That's resistance, but still was flowing the same amount. That is the same concept as voltage. Same concept. Now let's look at electron flow. The electron flow. It is flowing electrons through the circuit, and voltage. Voltage is the one pushing you around, moving that amps through the circuit. I'm just reiterating this on purpose so you understand what voltage is, what amperage is, and what is resistance. So with that, let's look at resistance. Resistance is the opposition of current. It's a material or a component that opposes the flow of current. So aluminum, copper, and some metals, they allow electrical current flow, has less electrons so they can flow through. Resistance is the opposition to current. Materials like rubber, ceramic, and silicone are great insulators. They do not flow electricity at all. In fact, they use those for capacitors. The lower the resistance, the more amperage will flow. Now, think of your certain things in your house. You have a light. Light has some sort of resistance producing light, current flow through resistance causing power. You have your heater to keep you warm, electrical heater. That again, amperage running through the coils, giving you heat. Oven and refrigerator. All these are making power because of resistance. And the unit for resistance is ohms. Understanding resistance can also help you understand why something is tripping, why something's not working right, why you have overloads in industrial settings, or sometimes you have a dead short, even at the home. You're like, oh, dead short. You do a quick resistance check. If you have 000, you have a short, you should have some sort of number that shows that you don't have a short producing amperage. That's one thing about learning about resistance. It helps you understand that. All right, I'm going to stop it there. All right, hold on. There it goes. I'm pushing. I'm Mr. Resistance. So that right there is an example of resistance pushing down the amps. The voltage is going to push, whatever it's going to push, but the resistance will change. And because of the size or the load of the resistance will allow a certain amount of amps to flow through. Same thing as a water faucet. As you slowly close, more resistance is happening, so you have less current. That is an example of current flow. So let's move on. What is power? Power, the rate of electrical energy transferred or converted to a circuit. Think of a heater. That heat coming from that heater is watts or power. That, by the way, unit is watts. That is power. Your heater. Other thing, think of your warming lamp when you're about to pick up that pretzel, the thing turning around, that warming lamp. That's usually a 250 watt light bulb heating your pretzel. That is watts. That is the power being used. That is the measurement of power. Again, think of your home. You have your electrical meter spinning, right? How does it measure that? Let me ask you, how does it measure that? So what I was measuring it is kilowatts per hour. So every kilowatt, that thing will turn per hour. It's measuring the wattage being used at your house. That's why it's very important to balance your electrical panel. If it's balanced, you won't have too much electrical load on one side of the current, of the phase. So that's what watts is. Watts is a cumulative of voltage, amperage, and resistance will give you watts. Let me show you some examples. We just did a quick run through in this episode 1 of Electrical 100. This is basically layman's term, just a quick understanding of electricity. Uses videos to help your students or for you to learn and help understand the electrical world. This is Sean Quinn from Tech Train Solutions, and stay tuned for more videos on how to be an electrician. This is number 1. Oh yeah.